Hello, this is Shaun from Roza Education and Research. In this video I'm going to talk about an interesting relationship between the powers of the golden ratio and the Fibonacci sequence. The golden ratio is defined to be 1 plus the square root of 5 all on 2. It is denoted by the Greek letter phi. It also has the property phi squared equals phi plus 1. We will verify this later in the video using the quadratic formula. The Fibonacci sequence is defined as starting with 1 followed by 1. Then every other term is the sum of the previous two terms, so the next term becomes 1 plus 1, which equals 2. The term after that becomes 2 plus 1, which equals 3. Then 3 plus 2 equals 5, 5 plus 3 equals 8, and so on and so forth. Now let's look at the powers of the golden ratio. We know phi to the power of 0 equals 1, and phi to the power of 1 equals phi. We also saw phi squared equals phi plus 1. Now let's say we want to calculate phi cubed. We multiply the equation phi squared equals phi plus 1 by phi to give phi cubed equals phi squared plus phi. Now we know phi squared equals phi plus 1, so we get phi cubed equals 2 phi plus 1. Now let's generalize this result by multiplying the equation phi squared equals phi plus 1 by phi to the n for some integer value of n. This gives phi to the n plus 2 equals phi to the n plus 1 plus phi to the n. This tells us if we want to find some power of phi, we just have to add the previous two powers of phi. This is the same relationship as a Fibonacci sequence. We can use this to calculate the next few powers of phi, i.e. phi to the 4 equals phi cubed plus phi squared, which equals 2 phi plus 1, plus phi plus 1, which equals 3 phi plus 2. In conclusion, if we call the nth Fibonacci number f of n, we see that phi to the n equals f of n times phi plus f of n minus 1. Looking back on what we did, the only property of phi we used is the fact that phi squared equals phi plus 1. Using the quadratic formula to solve the equation x squared equals x plus 1, we get two solutions. One of them is phi and the other is 1 minus the square root of 5 all on 2. This number is sometimes called psi. Since psi also has the property that psi squared equals psi plus 1, we can repeat the argument above to give psi to the n equals f of n psi plus f of n minus 1. Next, with a bit of algebra, we see that phi to the n minus psi to the n equals f of n all multiplied by phi minus psi. Rearranging this gives phi to the n minus psi to the n divided by phi minus psi equals f of n. Thanks for watching. What relationships between the golden ratio and the Fibonacci numbers can you prove by fiddling around with the definitions? Can you show the limit as n goes to infinity of f of n plus 1 divided by f of n equals phi?